Hey, welcome back. Welcome to the channel. Good to see you again. Thanks for joining. And today on the bench we have a nice little treat. This is a Pioneer SX626. This was brought to me by one of my clients. He wanted it repaired and some work done on it. And he told me this one has a little bit of a story behind it. The story being, he bought it off a gentleman about 14 years ago, I believe. He bought it off an older gentleman. And that person had bought this new in the 70s, and this was his pride and joy. But in his ownership, his wife got a little over carried away with the cleaning and used to buff the front of this every day with a cloth. And you can see all of the lettering is worn off. You can still read it if you really strain, but it's pretty much gone. So I don't know if she was using a chemical cleaner or if it was just from the repeated action of having this thing buffed every day. But yeah, she's maybe a little OCD on the cleaning, but stripped off all the lettering. Pioneer's still here. You can still feel it's raised, but the rest of it is gone. So yeah, I thought that was kind of unique, and I've never seen that before on a receiver of this vintage where it wears off. Usually you see it wear off on the volume control because your fingers are always rubbing, but here it's pretty consistent all across the face. It's all worn off. So anyways, he wants me to deal with this. He wants to so after he bought it, he used it for a few years and it sounded good, but then it started getting problems, scratchy pots and channels cutting in and out, and I think after a while he gave up on it and stopped. He pulled it from service to move on to something else that was a little more sounding better, and he put this in storage, and now he wants it repaired and refurbished so that it's back to where it should be. He also dropped off with this receiver. He dropped off the original owner's manual, which is kind of cool. We can have a look at this. A few things I found interesting about this 626 is it has 3 sets of speaker outputs. You got speaker A, B, and C, and you got a switch here that can allow you to choose combinations between the 3 sets. Bass and treble controls. It has a low filter, high filter, and an FM muting button. Normal balance control here in the center. And then next to the balance you have your volume pot. It has a good feel to it. No weird sounds like the last one. A loudness control, 2 tape monitors, and a mono stereo button. And then we have our input selector. It has a microphone input, an auxiliary microphone, 2 phono inputs, which is a nice treat. It has auto FM and mono FM AM band. So it's a nicely optioned little receiver. I don't know what the specs are on the power output. So this is cool. It gives you a breakdown of all the controls, how they work, what they do, and it even included a schematic, it appears, an original schematic. Well, this will be nice. Hopefully we won't need to use that. I don't want to get it dirty. So I'll put this back. It's nice touch. Specifications. Continuous power output 40 watts into 4 ohms, 32 watts into 8 ohms. Continuous power output both channels driven. Maybe I should be reading that one instead. 4 ohms is 30 plus 30. 8 ohms 27 plus 27. Harmonic distortion less than 1% at power output, and less than 0.09% at about 16 watts output. Power bandwidth 10 Hz to 70 kHz, less than 1% deviation from that. That's pretty good spec. It's got a mounting template. Look at this. It's got little instructions for doing your own tuner alignment. It's got for doing your own tuner alignment. That's pretty neat. I've never seen that in an owner's manual before. So one of the things Mike wanted me to address on this receiver was the faceplate, and he supplied me with a faceplate that he found online. I'm not sure where he found it, but it looks to be pretty good nick. So we'll fit this on, and we'll get rid of this other faceplate that has all the lettering worn off, and we'll turn this back into a nice running machine. He wants me also to address a lot of scratchy pots and channels cutting in and out. So let's just give it a little test on how it sounds. Getting a little. It doesn't have power on muting. It's picking up the stations good. I'm getting like 5 on the meter here, but the stereo has a little problem getting in tune. I think maybe my little wire antenna is not the greatest, but let's try AM.
To contain climate change. To, you know, flesh Ruby out a little bit.
Yeah, AM's working fine.
These may tell you to see better.
Okay. Let's feed it a tone and see what we can get out of the auxiliary. Actually, you know what? These pots are sounding clean. I don't see any. I don't hear anything going on with any of these pots. These switches seem okay. I'm wondering if he's got an internal problem where it cuts out. Could be a dirty speaker switch too. We don't know. Could try all the other speaker outlets. Yeah, this speaker switch is a little scratchy. Phono? Oh, there we lose the volume on the right channel. Phono 2. Yeah, we're losing the left channel. Okay. Let's have a look at the back. Alright, so for the back we have 2 phono inputs, which is nice. Your ground for the phono. An auxiliary input, 2 tape monitor loops. But here they are using tape 1. There's a little sticker here. It says ready for quadraphonic. No, it says ready for 4 channel. So this tape 2, they're using it as a 4 channel extension. I'm not sure how they're doing this. This is kind of a mystery to me. But they got tape loop 1, tape loop 2, and it says 4 channel in, 4 channel out. I don't know. Then we got 2 bridge jumpers for preamp out, main amplifier in. We have a DIN connector for the tape loop 1. We have 3 sets of speakers, and they use the Pioneer special plugs that Pioneer uses. I guess I don't know what they call these, but if you pull these out and lose them, then you're left at the mercy of the eBay parts scroungers to sell you a new one for probably 100 times what it's worth. So we put these back so we don't lose any of them. It's a shame some of them have little breaks or chips, but that's not much you can do about that. It gets beat up a little bit. We've got 2 protection fuses. I'm assuming these are for in the either in the speaker line or in the power going to the power amplifier. So these are 2 amps. That's correct. This one's 2 amp as well, so they're both correct. When you look original. A ferrite bar antenna for AM. You get superior AM with that, and it's outside of the cabinet, so you get a good reception with that. An AC fuse. AC line fuse. And this is supposed to be a 2 amp, and it is, so that's good. Our antenna inputs for AM FM, we have 2 courtesy outlets, 1 switched and 1 not. So what we got here is a lid with a vinyl wrap, and it's in fairly good condition. It just needs a clean. It's pretty good. And it looks like a plywood lid with a vinyl wrap. So very nice clean condition. It's not dirty at all. A little bit of dust. And a cage for our power amplifier. And this here is something with our tuner. Yeah, the tuner front end modules in this is what is it? 1, 2, 3, 4, 5, 6, 7 gang tuning capacitor. There's a looks like there's a printed circuit board on the back of this, and that's our front end. And this would be all the IF and the rest of the tuner. Power transformer. 1 little tiny capacitor. Not too little. It's fairly big, but it's by itself. I thought I'd see a pair. Everything else looks pretty good in the original. Hasn't been disturbed. Looks pretty clean. Okay, let's have a look, pull off the bottom, have a look at that too. All right. Ah, a lot of circuitry hiding under here. Everything looks original, undisturbed. Our tone control board here. And a couple switching boards. Nice access for cleaning. This thing here, I'm not sure what that is. It could be a phono amplifier equalizer. There's a power supply board here in the middle. Not much to it. There's a little couple of transistors. Another fuse hidden inside. I got this unplugged, by the way, so we might have a depth capacitor here. I have to change that out. 0.01 microfarad. Looks like an old oil capacitor. AC 800 volts. I wouldn't trust it. I'm going to replace that, I think. Not too much going on here. There's a couple white wires hanging. I guess this must be for the, maybe for the bias adjustment. They're bringing the connection out. A few cobwebs. We'll chase the bugs out. Power amplifier looks pretty clean. It looks untouched. The original settings are still sealed with the paint on the potentiometer trimmers. So I don't think anybody's ever done any work to this thing. I think it's all pristine and original. So we'll go through and we'll see what it needs. I'm not going to go crazy with doing a full recap. I'm just going to test capacitors and make sure they're all good. I noticed there were some bumps and thumps on the audio amplifier when you're powering it up and shutting it down, so we might have some tired caps in there, and I expect to find some tired caps in there and in the power supply as well, but it's still holding up pretty good for its age. I was just going through taking covers off and having a little inspection, and I found something already that was probably cause of his channel cutting out issue. Here's a power amplifier. We got a little heat sink here. It's probably about 2 inches tall by about 7 inches wide, and it's got 4 transistors down in here, and you can see that they're soldered on the back side to the printed circuit board. These ones look good. These ones look good. This one here, both of these joints have cracks in them, and this one here in the top, I think it's completely severed. This one doesn't look too bad, but it's cracked on the bottom of the joint. You can't see it. The top looks fine, and this one looks okay. But I think that's the cause of our problem right there with channel cutting out. And that would make sense because there's really no relay here. There's no well, there is a speaker switch which would be in the path, the signal path, but this would be the cause of the problem right here. This. So we'll take that all out and we'll deal with that. All right, time for a little update. Not much going on here. Pretty unexciting. The only thing I found really was that cracked solder on the transistor leads for that output amplifier. I did recap the power amp, and I put I don't know how many. I put maybe 10 caps in here. The 2 speaker output capacitors, I'm going to leave them back in. I pulled these out and tested them. These are actually power supply filters, and they repurposed them for speaker output DC blocking capacitors. I'll put these back in because they do measure good, and they have a low ESR, and they're still working, so why not? And other than that, I'm not finding any bad caps anywhere. There's a checked tone board. Everything is good, but I still might go in and replace the caps that are in the signal path with new ones, audio grade. The power supply, I replaced 2 caps, left the other 2 in because they tested fine. So yeah, it's nothing. I haven't really found any bad caps yet. I'm just finding some that are borderline. I'm going to get rid of this thing though. This is starting to bug me. This cap here. This thing here, I think it's either a paper or an oil cap. Pull it out. 0.1 microfarad, 0.01 microfarad, AC 800 volts. Maybe back in the day this was cutting edge, but I'm going to put a proper XY rated capacitor in here. They have it line cord coming in, going to the courtesy outlets, and then to the transformer. The other one comes in, goes to the courtesy outlet, goes to the power switch, comes back, goes to the other courtesy outlet, goes to the fuse, and then to the transformer. And this was placed between the one leg of the line and the transformer lead, so I'm going to put this back. I'll clean up these terminals first and then put that back. But other than that, there's really not much to talk about here. Not much going on. It's pretty pristine condition. So I'm just going through doing my work on the underside, the undercarriage of this receiver. Every time I step away and I come back and I sit here, and it's just marvelous, the build quality of these things. This thing was mid to early 70s. I can tell just by the assembly style. The board's sitting up on standoffs and everything's point-to-point wired. There's no plug-in harnesses. It was all wire wrapped. The build qualities in these are phenomenal. And if you ever get yourself an old Pioneer, just hang on to it. I think that's the best solution. Just keep it going, because they don't make these in like this anymore. Anyways, enough of my rambling. Basically here to show you what I'm doing. I recapped the power supply with the exception of the 2 output capacitors. They pulled them out, tested fine. There's 6 capacitors on the phono equalization board, and I checked them. A lot of them had a high ESR, and the values were out of tolerance on the high end of the scale, which leads me to suspect that they were leaky. So they're all getting brand new, and in the audio path I'm putting audio capacitors. And I did the power supply. These 2 capacitors I left because I pulled them out and tested them. They were 100% fine, but I replaced 2 other ones because they were high ESR. Here's the tone board. Same thing. I suspect I'm going to go through all these capacitors, and I'll probably end up replacing all of them, if not most of them, just because of the ESR and the drift in the tolerance, or the drift in the value would be out of tolerance. And then aside from that, we're pretty much done. We got a little bit of switch cleaning to do. I'm not going to touch the potentiometers because for my initial tests they were quiet, and I'm not going to spray anything into them, just because, if it ain't broke, don't fix it kind of thing. So I'm going to leave those alone, leave these potentiometers alone, and leave these ones alone. These switches, though, I want to clean. My client Mike, when he dropped off this receiver, he also gave me a little gift. He made a donation to the channel. He says, here, you take this. It's Canada Deoxit D5. I have the concentrate, but the D5 I don't have. And in some instances, this is actually better to use than the concentrate, because you can spray it in to areas where you can't reach. And I think I'm going to use it on these switches. Even though the switches aren't sticking or scratchy or cutting out, I'm still going to give them a treatment with the D5, and I'm just going to do that, and hopefully they'll be good for a long time. So thanks again, Mike, for the donation. This is a generous offer. I really appreciate this. I know this ain't cheap. I know I haven't looked at the price of these, but I know it doesn't come easy, these cans of deoxit. So you want to use it sparingly. Just use a little bit on each switch, and I'll do that after I'm finished recapping this or reworking this board, and I'll see how it turns out. Another thing I do when I'm finished is I go through and I clean all the flux off the back and give it a good inspection. Haven't found any cold solder joints or cracked solders aside from that one on the power transistor on the power amplifier, but I'm still looking, and you got to make sure that everything's good before we put it all back together. Okay, so if you read the can on a typical deoxit D5, well, any deoxit D5, if you read the can, it has at the bottom here, well, it's got directions on how to use it, and it's got a little blurb here on what you can use it on, and there's no mention, if you read through it, there's no mention of potentiometers. So keep that aware. Don't spray this stuff into potentiometers. Even though it will help them if they're really bad, it's not recommended, because this stuff is I got no idea what kind of solvents they use in this. It could be really aggressive solvents, but this is mainly a product that's intended for connectors and switches, and yeah, so keep it at that. So it says here, all metal electronic connections, audio video, computers, cables, rechargeable devices, flashlights, switches, contacts, phones, plug sockets, batteries, headphones, toys, cameras, lighting, electronics, industrial equipment, and many more. Doesn't go into too much detail, just gives you a kind of a general. But we use this on switches. I'll show you what I do. These Pioneers, they have the nice little cutout on top. So I just give the straw a little positioning here and give it a short burst and just work it. I'll work it like this for maybe 30 seconds or a minute. And then what I'll do is I'll give it another shot, a second one, and work it again. Sometimes it's nice to have a rag here if the stuff drips out. But you don't have to give it much of a blast. Just give it a little short squirt. And the stuff gets in there, and that's basically all it needs. I just do the next one. The bigger switches, you might have to give it an extra shot to get it, because you want the liquid to travel to the end of the switch inside. And it mostly does that with capillary action. You know, once it gets in there, it just wants to dissipate in all directions. So yeah, I'll give it a second shot. And just go through each switch and do this. And it should improve your contacts. Now, also, these work good. This works good on these rotary switches. I'm going to have to clean that. It's very stiff. But I'll get in and I'll spray the contacts on each of these wafers. There's 5 wafers in here, and I'll get in there and I'll give them a shot too, and then I'll work it back and forth for a minute or so. I'm also going to apply some lubrication to the ball bearing, which gives it the detent feel. It's actually quite stiff, and I might have to put some oil on the shaft here, and here, just to get this thing to roll better. Yeah, and I also forgot to mention this Deoxit D5. Do not use this or any other Deoxit product on power switches. Power switches are unique in that they have dry silver contacts in them, and as they work, they have a wiping action against the contacts against each other, and that's what keeps them clean. If you have a problem with power switch, if somebody sprays this stuff in, it leaves a oily residue, which actually is harmful to power switches. So yeah, don't use this. If you find that you have a power switch that needs cleaning, get something like Electrosolve that's a zero residue and use this to flush it out. But remember that this is zero residue. It's going to flush out any lubricants that was placed inside the switch for its smooth operation. It's going to really strip everything that's inside that switch. If you have a bad power switch, best just to replace it, not fool around with it, because it's, you know, it's a safety item. But if you can't find a replacement, next best thing is disassemble the switch and clean it manually. And that way you know that the parts that need lubrication will be lubricated and the parts that need to be dry will stay dry. But this will flush out anything. It will flush out all the dirt, contaminants, and it'll also flush out all the lubricants that's in there. So a little bit on power switches. Okay, we're on the home stretch here. Just ready to put it back together. Let's have a look at this. All right. Yeah, it looks very good. I don't know if that's a stain. I think that's just a stain. I have to clean that. I think, well, it's dirty for sure. It's got some cobwebs and some fogging on the inside of the glass from a little bit dirty on the outside, but we can clean that up. But I would just try and look at the condition of the side, condition of the wood on the side. Looks like the original one's maybe a little better. I might just transfer these wood end caps to the new one, because this one's a little beat up here. Or is it just dirty? Got a little chip here in the corner. This one looks okay. A dent on the top. But I think these ones are nicer. So I think I might just transfer these two onto the new one and make it that much better. All right. But you can see the difference. Not too much of a difference. I don't know if you can see this on camera, but the lettering is a huge difference. But they're both pristine condition. No big gouges or scratches. Just one has all the lettering worn off. It's the only fault here. So what I'm going to do is like I said, I'm going to transfer these wood end pieces over to the new faceplate. We'll clean her all up, put her on. Now we have a little problem on our hands here. The service manual stops helping us at this point. What we want to do is we want to adjust the bias and the DC offset on this amplifier, but there's no mention of those adjustments in the service manual. And there's no mention of it on the schematic, what these values should be. We just have to use our better judgment and our experience as to what it should be, or what we think it should be. There's 4 pots on this board, 2 for each channel. I'm assuming the white pot with the yellow paint on it is our bias adjustment. And let's see here, I got a schematic of the amplifier. So this VR4, VR3 is 100 ohm potentiometer, and that would be our bias current setting because it's right in the bias circuit here. And I think that's these are 2 white ones. But then we also have a potentiometer up here close to the front end of the amplifier. It's a 30K VR1 and VR2 right here and here. And I'm assuming, since it is right at the beginning of the feedback loop here, this will be setting the DC offset of the amplifier when it's at idle and not doing anything. So how do we do this? Well, we could just hook up an ammeter here across one of these resistors and measure the current through it, which we could do. Pioneer was nice enough to insert a wire, this white wire sticking up out of nowhere. It seems because it comes away from back here, and they brought it out to the back or to the bottom for us. So that would be one of our connections on the resistor, but we'd have to figure out where our other one is. We have to look at the schematic and figure out where we hook our other lead. It's not really clear as to what we do here. So first thing is, we can't just simply hook up a voltmeter to the speaker output and show us our offset. Here, I'll show you. For example, I got a voltmeter here hooked. One's connected to ground, one's connected to the speaker output terminal. Let me turn it on. And wow, it goes up over 20 volts, 24 volts, 22 volts, and then it starts its drop. So what's going on here? Well, actually, we're measuring the voltage through this capacitor. This capacitor is probably slightly leaky, and it's allowing a DC current to flow through it, which is what my meter's picking up right now. It's dropping down to 9 volts, 8 volts. So as the amplifier turns on and stabilizes, these capacitors will charge up to approximately half the supply voltage, which is, I think on this is 50 volts total on the B+. And then our junction between the 2 output transistors should be approximately half that voltage. So it should be about 25 volts where this sits. And this capacitor here on the output of the speaker, that's our DC blocking capacitor. That's to stop the 25 volts from going out to our speaker. It's to allow the AC signal to pass through, but no DC signal. But as you can see here, we are getting a DC signal through it, and it's dropping down. It's down around 1 volt now. So what is that leakage? How do we know? Is it a bad leakage? Is it acceptable? So what I've done on speaker system C, this is speaker system C, I attached 2 100 ohm resistors. And I checked the resistance of these. This one's bang on, this one's about 0.5% out. So they're pretty close to 100 ohms. So that will be our load, 100 ohm resistor. Oh, this one's still loose. Tighten it down. Okay, this is our known load of 100 ohms. So now that we know we have 100 ohms across our speaker terminals, we can actually do some calculations. So let's turn on speaker C here. Okay, I'm on speaker C, and you can see that the voltage drops to almost nothing. Turn this up to millivolts, and we'll see it jumping around 5, 6, 4, 3, 7 millivolts, right? So that's actual current that's leaking through the capacitor and into that 100 ohm resistor, because I'm measuring across a 100 ohm resistor now. Now we can do the math on this, and we can see that our capacitor is leaking about 100, probably between 50 and 100 microamps, which is probably acceptable. I'm not going to say it's perfect, because it's not, but 100 microamps on an 8 ohm speaker is absolutely nothing. So that DC blocking capacitor is pretty much doing its job. Let's check the other channel. I'll go up to the other speaker terminal, and same thing. It's jumping around between 0 and, let's say, 10 millivolts. Why is it jumping around? Well, I don't know. Maybe that capacitor is here, let's do this again. Let's hook up an analog meter, and I can show you. Analog meter shows this much better. Let's zoom in. So I don't know if you can see this. I have my voltmeter set to 300 millivolts full scale. So we're using this scale here, and so this would be 50 microvolts, 50 millivolts, 100 millivolts, 150, 200, and so on. So our needle is jumping between 0 and 10 millivolts. You can see it moving there. It's kind of floating up and down. I think that's just the leakage current in the capacitor itself. Let's try the other channel again. Connect this to the other channel, and you can see it's the same thing. So we can't go in there and tweak our DC offset with a voltmeter hooked up to the output, because we will not get any result that we need to see. So how do we do that? We need to come about this a different way. So in order to adjust the DC offset here and here, what we're going to need to do is we're going to need to feed in a signal on do one channel at a time or both, whatever, and we're going to need to feed it in at a sufficient amplitude to cause this amplifier to clip. And what we're going to do is we're going to adjust this potentiometer here so that we have equal clipping on the top and then the positive and the negative rails output. If we hook up our scope and we have clipping on the top only and no clipping on the bottom, then we know our balance is off and we need to adjust it so that we have equal clipping on the top and the bottom. And that's what we're going to focus on right now. And I can use the 100 ohm resistor as my dummy load, because we don't need to push a lot of current through the amplifier. We just need to set its balance points. Okay, so I'm all wired in for doing the balance test. Let's get a suitable screwdriver here. Now, I got a signal feeding in. I can turn it up. You can see it on the scope. If I keep cranking it up, you can see the bottom goes into clipping before the top does. So we want to fix that. So what we'll do is we'll do one channel at a time. Let's turn the balance. Let's turn the balance and do this channel first. So keep turning it up till we get clipping. And let's adjust this potentiometer here. And we are going to adjust, I'm not even sure which one it is, but It's this one here. Okay, so right about there we got equal clipping top and bottom. Let's turn it down a bit. If I crank it, the bottom really clips. I think we're there, right there. If I tweak the volume, they both start clipping at the same time. That's what we want. Okay, I'm going to leave that one. Let's go to the other channel. Okay, so we're on channel 2 right now. This is the, I'm not sure which channel this is. This is the left channel I'm doing. Left channel's up here. So let's turn this up. You can see it clips quite a bit before the if I turn it counterclockwise, it gets worse. So we need to increase this clockwise until our clipping is on both. A little more. Right about there, I think. Seems I got clipping on bottom and top equal. Right there, I'm going to leave that. Okay, so we're done. Okay, now let's set up the bias adjustment. From what I can tell, this little white wire comes from the one side of the emitter resistor, and the other side of the emitter resistor is accessible by sticking a clip lead on top here. And this might be pretty janky setup, but we'll try it out. Okay, so I got that connected. Let's turn on the power. And we're getting about 4.5 millivolts. What I'll do is I'll let this warm up. It has been on for a while now. I just did the DC balance adjustment, and the amplifier is warm to the touch, so it's probably going to need some cooling off period. So I'll let this sit for about 10 minutes, and we'll see how this changes. I think my target here is going to be about 10 millivolts, 10 to 15 millivolts. That should put through enough current. We could do the math, but we could figure out that would probably be in the order of 30 milliamps for those transistors. They're pretty beefy transistors. I'm not worried about that. I think I'd rather have them biased on a little bit heavy than having them biased a little too little, and compromising the sound quality. But I think we're going to be okay. It seems to be cooling down and it's climbing. So we might not be making any adjustment here at all. We might be just adjusting it downward. We're almost at 12 millivolts. But like I said, I'll let this sit for 10 minutes. Okay, it's been sitting idling for a long time now, quite about 10 minutes, 15 minutes. And we have an idling bias current or voltage of 17.2 millivolts across a half ohm resistor. Or is it? Yeah, it's a 0.5 ohms. I think that's a little high, but you know what? I'm not going to touch it, because touching this amplifier on the top here is a little warm. The one on the bottom is a little cooler. Let's switch our leads around and see what the other amplifier reads. I have to flip the amplifier over, so bear with me. Okay, ready to check the other channel. Turn it on. So I turned this on and it started off at 0, so I'm just going to give it some minutes to climb here. I don't know why I only shut it off for a minute or so. I had to disconnect the shield and get my clip in from behind because there's no way to get it from below. So I'll just let this climb and see where it settles. It might be the other channel's a little too high, and this one's probably more precise on where it should be. We'll let this go for a while. Okay, so I think this channel here is probably more correct. 10 millivolts sounds like a nominal value, and this is typical of some of the Harman Kardon amplifiers that use the same the amplifier design. They have about a 10 millivolt bias setting. So what I'm going to do is I'm going to go back and I'm going to change this other channel from 17 or 18 down to 10, and I'm going to have these both balanced, and that's where I'm going to leave it. Alright, so we're all wired in to do a power test. I just want to see, Pioneer makes some really good claims here in the specification page, but we'll see what it actually is. Let's see here. Power amplifier section. Continuous power output, both channels driven. 30 plus 30 watts into 4 ohms, 27 plus 27 watts into 8 ohms. That seems like a realistic amount. For a capacitor coupled output, I don't know if we're going to get that, but we're going to try. Music power output, IHF, 110 watts into 4 ohms, 76 watts into 8 ohms. I think they're doing both channels added together. I don't know. We're going to figure it out here right quick. Okay, so I'm all wired in for a power test. I think you should be able to see the scope on the screen. Let's turn it on. I have my load connected to speaker C, so let's tune speaker C in. And we can turn up the volume. And we got our probes probably set wrong. So let's fix that. Let's put them both on times 10, and then we can turn this up. Okay, getting our clipping there. Seems like we're getting a lot of clipping from the sag in the power supply. So let's put our clipping level right about here. I think that's where it stops. We're getting 13.58 volts RMS into 8 ohms. Let's measure that sag. Okay, so here's our power supply voltage, rail voltage. It's 57.3. Let's take it up to full power. And we're dropping down to about 50 volts. .3 from 57.2. So we're getting about 13% sag in the voltage from the power supply, which is kind of high. I'm just wondering if a bigger capacitor would be beneficial in this thing. Seems like that capacitor is struggling a little bit. What I'm going to do is I'm going to upgrade this to 8200, and we'll see how it performs after that. Alright, so I removed the 3300 microfarad and I replaced it with an 8200 microfarad. It's half the size and it's 2.5 times the capacity. But this should give us a little more grunt in the power supply. As far as anything else to do with the power supply, I don't think changing diodes or anything is necessary. This isn't that drastic of a change, so let's turn this on. And we see we still got our 57 volts, 57.4 volts. Okay, so let's turn up the volume and see what we can get for an output here. I need to turn on speaker C, and then let's turn this up. I still have my voltmeter connected, yes, okay. Take it up to clipping. A little better behaved now. I would say right there I'm getting 13.69. I don't think that's changed any. And our power supply still sagged to the same amount, so really no change. Maybe I'll just pop that other one back in. But let's see, that does it for this receiver. Let's put it through its paces now. I can't believe that. Let's try that again. .59 volts RMS out. Let's give it a little time to see how it warms up. Well, there it is, all back together. It's a nice little receiver. I did replace the, I put back in the original 3300 microfarad power supply capacitor because upgrading it didn't make any difference in performance or sound, so I just left it. And it was doing its job. It tested fine on my tester and everything was good, so that stays unchanged. Everything else has been done. I replaced probably 20-30 capacitors here. Some of these are borderline, some of these have failed, some of them have like twice the times ESR they should have. I replaced a pilot lamp that was burned out. So gone through all the circuits, everything's been looked after. No noisy transistors. I did try swapping a few transistors around and it didn't make any hill of beans difference, so I just left it alone. But yeah, I got the new faceplate on, it all looks good. So I'm gonna give my client a call and let him know his receiver's ready. But first I'm gonna listen to it for a week or two. I'm gonna make sure it's 100% before I give it back to him. So thanks for watching, and we'll see you on the next one. Take care.